This is lesson 53 of the Quantum Mechanics, a mini lecture series, vectors part 5. So often in maths and in quantum mechanics, vectors are usually expressed as columns. Okay, here's an example. Suppose I give you this, 1, 2, 3. So generally speaking, the top number here, the 1, is the x coordinate. The middle number, the 2, is the y coordinate. And the last number in this case is the z coordinate, okay? So x running across the page, y going up and down, z coming out of the page. Okay, and as such, this vector is three-dimensional. It's living in three-dimensional space because there's 3 components. Okay, these 3 numbers here, they're called components. And you can do many things to vectors. You can add them together, you can subtract them, and so on and so forth. I'm not going to go through all these properties, but I'll give you some examples. So suppose you've got 2 vectors, v1, 2, 3. Okay, 2 vectors written as columns, 4, 5, 6. To add them, what you do is you simply add each respective component in the first vector with its corresponding component in the second vector. So v plus w is just 1 plus 4. Okay, these are the x components. Then 2 plus 5, these are the y components. And then 3 plus 6, these are the z components. Doing the maths, you get 5, 7, 9. Okay, this also applies to vectors of high dimensions. Let's suppose you have 100 components, so a vector living in 100 dimensions. You can also do the same thing here. Another property is that of multiplication. You can multiply a vector by some number called a scalar. Okay, that's a scalar, it's a number, the 2 in this case. That's a vector v, let's call it v. And what you're effectively doing graphically, is, if you think about it, is you're basically making the arrow, okay? So here's a vector, vector's like an arrow. You're making the length of the arrow longer than it was before. Okay, in this case, you're doubling it. That's what multiply by 2 means. So you get 2 times 1, 2 times 2, 2 times 3. You just multiply the 2 with each component of the vector. You do the maths, you get 2, 4, 6. As an exercise, try and work these out. So the addition of 2 vectors, and try this out, multiplication of a vector by a scalar. It's the same idea, okay? So just the addition of vectors, you're adding the individual components. Multiplication, you're just multiplying each component by the scalar.